Howdy, folks. Today's lesson is part 1 of SAS 9, and it's an introduction to statistical bias and variability. We briefly discussed bias in class, but I'm going to go into some detail about this. Look at this bell ringer. This kind of gives us a little bit of an idea. According to a recent survey of my students in AQR, the average age of a Rudder High School student is 18. What do you think of this conclusion? Do you think this is correct? Do you think all students in Rudder High School are around the age of 18? And if so, where do you base your information off of? My information came from polling my students in my class. So if that's not correct, where do you think I made my problem at? Let's think about that for a second. I think you can probably figure it out pretty easily. I've discussed this with a few of my classes, and I think you understand that. But in the meantime, let's go on and move on. If you haven't figured it out, please get with me, and I'll tell you why this is not correct. Okay, so good things. Let's see, a good thing. I am ready for spring break already to come. I'm going to build myself a little sleep cabin to put on our property so that we can all have close to our own space instead of all jumbled up in one room, which is not fun when you got a bunch of kids and family in the house. And that's always a good thing. So that's my good thing. Please take the time to share your good things with me via email. That would be great. I love to share kids' good things. Few good things happened in my class. I got visited by some very, very recent graduates. Really good to see them, even though they just finished school in December. I won't see them a whole lot. They'll be leaving for boot camp, and it's really nice to see them before they leave. Those people that are willing to do that for us, we need to really pray for them or think a lot about them, because they're signing their name on a dotted line payable up to their death for our freedom. And I think it's really awesome that a child, and I call them a child because they're only 18, they just now became an adult. A child, someone that just became an adult, is willing to sacrifice their lives for our freedom. And they know that that's part of the deal. Anyway, that's my good thing. Please, like I said, share your good things with me. I'd love to share them with your fellow students. All right, so let's recall the spud potato chips one last time. We talked about this last semester in order to talk about it again. One sample that was collected had the results shown below. If the true mean of all Spud's bags is really 28.3 grams, as claimed by the company, this sample appears to have some major problems. Sample mean is far below the true mean. It says man, it should say mean. And in fact, all the bags are below the true mean. As you can see, that's a problem. The mean, the sample mean is 25.16. This is the, what do they call that? Measure of spread outness. I can't remember the name of it. I'll get it before the end of the video. I'm almost sure of it. The measure of spread outness, statistical something. I can't think. Let's just move on. So the discrepancy between a population parameter and a sample statistic is known as statistical bias, which can result from many different sources. Two broad categories of statistical bias are biased sampling method and biased statistic. What is a biased sampling method? I wonder if we really get into it too much in this video, but I want you to understand a biased sampling method that we discussed this in the last video. Let's say we were to poll or survey a sample of the population of Bryan, Texas, and we only asked people that live over on Sandy Creek, way out there by the lake. Are we really getting the demographics of the city if we only poll people out there? No, we're not. Okay. And the other one is biased statistics. Can you give an example of a biased sampling method? Yes, there's several. Here's one. When the class served as a sample for the entire high school. There you go. There's your answer to that bell ringer. You used a biased sampling method. The students in my AQR are much older than most of the students here at Rudder. And if you collected all the potato chip bags from a single vending machine, a biased sample might result. You see what I'm saying? If you just get bags from one selection or one area, you might not get a good result of all the bags that come off the line. All right. Sometimes researchers spend vast resources, time, money, effort to get a great sample, and then they still end up with a biased statistic. For example, something could be wrong with the data collection method. What could happen after selecting the sample, for example, potato chip bags, and before calculating the statistics that could result in a biased statistic? The scales could be inaccurate. Now, that would screw everything up now, wouldn't it? Or personal preferences took precedence over accuracy by the researcher, and only certain responses were recorded. And we discussed this in class. What happens when a researcher has a foregone conclusion to their survey, and they want to make sure that even though the data is coming in showing that what they believe isn't true, they get rid of some of the samples so that their accuracy fits what they believe. And that happens a lot today, and it's really sad. Objectivity is really going out the window. All right. If, in fact, the method of sampling has introduced bias, one reason for this might be that the sample was actually non-representative of the population. That's non-representative sampling. And we discussed this. It's when the sample does not represent the differences in a population. For example, we poll the Bryan population and we get a sample from just one area of town. Austin's Colony is where we get our sample from. That's obviously does not befit the demographics of the entire town. Students in the class are mainly seniors in my high school, therefore they don't represent all the students in the school. That's a good way to do that. If only the volleyball team were surveyed at most schools, the sample would have either all males or all females. That doesn't fit the demographics of the school, and it doesn't give you a good survey sample. All right, what other situation could be responsible for bias? And it says provide examples where possible. Here's one. Undercoverage occurs when entire segments of the population are missed. Exactly. That's what I'm talking about when we say non-representative sample. Undercoverage means we missed an entire part of the population. So if there's a section of places that people do not actually get surveyed, they get missed. In the class example, freshmen, sophomores, and many juniors would be missed. In the broad population, homeless people, people in prisons, people without phones and so forth might be missed. Several errors are possible in implementing the chosen sampling method. Perhaps the strata are not identified properly when you use stratified sampling, or clusters were not well defined, creating overlapping subsets of the population that introduce the possibility of a response being repeated. That's kind of a problem, isn't it? Okay, so bias statistics can result from a variety of problems during the data collection process. Here's some ideas why bias happens regarding each of the following sources of statistical bias. Response bias. Response bias is that responders like to lie. Perhaps they're embarrassed to give the real opinion or to tell the truth regarding their past criminal history. That's something that might come up. They also have a faulty memory, and they may want to impress or do not like the interviewer, and so their answers may be not true because of that. Bias statistics can result from a variety of problems. Here's another one, response bias. That's amazing. It's the same slide, just a little bit different. I need to delete that of the slide. I'm going to go ahead and do that. I know this is kind of an issue for y'all, but it really is simple to do. So there we go. Okay, back to it. Next slide. Non-response bias. Now, this is the exact opposite. This is people that just don't do the survey. Intended participants are out of contact or refuse to participate. Observer effect. Now, this is a strange one. You football players or volleyball players or softball players or tennis players out there, you're out playing on the court and you notice someone you recognize as a head coach for the team that you're really interested in going to play for in D1 NCAA. And you want to impress them. You're not going to act like you do to your regular coach, do you? You're not going to be all talk back and stuff. You're going to be yes sir, no sir, and you're going to play your best game. That's called observer effect. They act differently than they normally would when they know they are part of a study or when they know they're actually being watched or they know something's going on. It's called showing up or showing off, whatever you want to call it, but that's what it's called, observer effect. Wording of questions. This was all a part of the last lesson. We have to word our questions in order not to sway the answers of our participants. Questions is worded to persuade participants to answer in a certain way. Placebo effect. We already know what this is. people who are ill or in pain want a treatment to work so badly they convince themselves psychologically that it works, and they're told the treatment will work, and so therefore they believe it does. All right, I'm going to launch you with this. Did you know that statistics show that teenage pregnancy drops dramatically after age 20? I'll let you think about that for a minute. All right, I'm done. So here we go. Don't forget to do the lesson. This is part 1, SAS 9. I'm going to post it. It should come up Friday morning, and it should be due Friday night. In the meantime, y'all, be blessed and be a blessing.